the switch in the figure, which is right here, has been closed for a long time. The switch has been closed for a long time. At t equals to 0, it is open. That means it goes open at t equals to 0. The equation for the voltage V of t for t greater than 0 is of the form V of t equals to a plus b times e to the power negative t over tau. The values of a, b, and tau are most nearly what? That's what we have to find out. If you look at it over here, you have a voltage source, DC voltage source. You got 6 volts. You have a 1 kilo ohm resistor, a 2 kilo ohm resistor here, and then finally you have a capacitor over here. So first thing first, at t equals to 0, this is when the voltage, not the voltage, but the switch is basically open. If you find the voltage at t equals to 0, which is basically just simply applying a voltage divider here, correct? Whatever the voltage over here across this resistor, same voltage will be here across this capacitor because the two are parallel to each other, correct? So simply applying voltage divider, V of 0 equals to total voltage, which is 6 volts, time the component across which you are trying to find out the voltage, which is 2 kilo ohm resistor right here, divided by the total resistance, which is 2k plus 1 kilo ohm, total of 3 kilo ohms here. And if we do the math here, 6 times 2 is 12k. 12k over 3k, that is going to give us 4 volts, correct? Pretty simple. Okay, now given R equals to 2 kilo ohm and capacitor here is given 3 microfarad, we can find out the tau, which is the time constant, R times C. And if I plug in the two values in this equation, 2 kilo ohm times 3 microfarad, I get 6 millisecond. So these are important piece of information because we were looking for this, correct? And this is also, remember, 4 volts, V of 0. Now next thing, we also know that V of 0, now we are looking at this equation here, okay? If you look at this equation, if you're trying to find out V of 0, which means this t is going to be 0, and if this whole thing is 0, then e to the power 0 is 1. So V of 0 is basically just simply a plus b dot 1, because e to the power negative t over tau is just simply 1. So you get a plus b here, correct? Now V of 0, we have already figured out it's 4. So I can rewrite this equation as 4 equals to a plus b, correct? Now if I need to find out the values for a plus a and b, then what if we need to find out basically V of infinity here, correct? V of infinity would mean a plus b times e to the power, t is going to be negative. So if you have t over tau, t being infinity, which it is, the whole thing is going to be infinity. So, and remember that e to the power negative infinity is always going to be 0. E to the power infinity is going to be infinity. So because this thing is going to be 0, this whole term will basically just cancel out, right? B times 0 is 0, so you get a here, correct? So a is just simply going to be 0. And now B is going to be what? Well, knowing that A is 0, if I plug in A equals to 0 in this equation, B becomes 4, correct? So these were the parameters we were looking for. B is going to be 4 and A is going to be just simply 0. Remember that V of infinity is always going to be 0, and the reason for that is 0 is because over a period of time the charge that built up at the capacitor is going to drop off and eventually it's going to go to 0. Hence 0 equals to A plus 0, and hence A equals to 0. Okay, this thing over time will become 0 volts. Okay, this product is 0, so therefore means A equals to 0.